So if you're watching this as a stream, I highly recommend that you go back and look at all these look at the previous stream that we did for the XML. Even that was XML based, we had some time at the end, so we decided to cover a bit of Java. So we covered a lot of information. So I highly recommend that if you're watching this as a stream and you're trying to learn Java, then you go back and review the information in the previous stream.
Wait, sorry, Krish. Can you just say that again? I forgot. I didn't set up the desktop audio properly.
Okay.
So
Yeah.
let me just redo that and um. So okay,
Are you,
just
are you
say it in
ready
like
now?
say it now. You should be good to go now. Yeah.
Okay. Alright, so if you guys are
Oh
watching
wait,
this
wait,
as
wait,
a
wait. Sorry. Um, settings. Okay, say something.
Hello?
Yeah. Okay, you're good.
Okay, so if you guys are watching this as a stream, I highly recommend, trying to learn Java, I highly recommend you go back to the previous stream that we did with XML and go towards the end of that stream because we had a bit of extra time at that class and we reviewed a lot of information right here. So if you're trying to learn Java, it's essential that you learn this stuff before we kind of start on this class. So definitely do review that and we'll get started now. So I think I explained this analogy. So yeah, this kind of just details that analogy a bit further. We have a sticky note with a name, and we can kind of assign, or this is actually representative of us assigning a new value to a variable. If I assign one, if I assign say the value 3.84 to the variable number, then I can always reassign number to the value 2.65, and that's simply done by just having this code right here. I would, instead of saying double, you only need to say double once. Whenever you're declaring a variable, you have to say the type, but after that the compiler understands that data is of type double. So if I wanted to redefine this, then I would say data equals, I think it was 2.65, and then from then on data will be equal to 2.65. If I say that below this line of code somewhere in my class or somewhere in my method, then data will now be equal to 2.65. So you can also move around these sticky notes, just like how you can kind of just peel off a sticky note and put it on somewhere else. The same thing you can do with variables. You can easily redefine variables to your heart's content. So it's not like a permanent kind of thing. Like if you define numbers 3.84, you can always change that. You can always redefine the variables. You can always change the information. So that's kind of what this is showing. I can take the number sticky note off and I can put it on a sheet that says 2.65. So yeah, we're going to talk a bit more about in detail about declaring a
I have a
variable.
question.
Yeah, go ahead.
So when you redefine a variable, can you redefine it as a different data type?
No, you cannot. So that's a really good question. I'm glad you asked that. You have to stick to the data type that you have. Like for example, if I have, data is equal to 3.84 and I try to assign it to the text hello world, that's gonna have an error. So never do that. You have to keep it to the same data type. Very good question though. Can we move on now?
Yes.
Okay, awesome. So now we're going to talk a bit more in detail about declaring a variable, and I think Ayush can talk about some of these primitive data types.
Yeah. Okay. So there's basically four main primitive data types in Java. So the first one is int, and that basically stands for integer, and that represents basically any whole number you can think of. So 2, 4, 6, 3, anything that doesn't have a decimal with it is considered an int. It could be a negative number as well, but the only restriction is that it can't be a decimal or a fraction. It needs to be a whole number. The next primitive data type is double, which stores a decimal number, and that's how you store if you want to do like 3.14 or 5.6. And this you in a double type you can also store like a 5 or 6, but it will always convert it to like 5.0 or 6.0. So that's important to remember. For a string, this one's like important. The format of it, the data type is always capitalized. So you want to take note of that because, as you
Yeah,
can
please
see,
look at
int,
it.
double, and boolean, all of the first letters are not capitalized, but for a string, since it's part of since string is an actual class, it's actually capitalized. And we'll explain what a class means later on, but you need to understand that you'll always have to make a string capitalized, otherwise you're going to get an error. And a string, as we said, stores any type of text. So and you always have to put it in quotations. And we'll show you an example of this, but for int and double, as we did before, you didn't really have to put it in quotation marks. You just said equals this, right? But for anything that you're storing text with, you would have to do it within quotation marks. And then a boolean is the last data type, and a boolean allows you to store a true or false variable. So, for example, if you want something to be true when something happens, then you could use a boolean. So you can it's basically to do logic. If you want logic in your programming, if you want to say, hey, I want to do this if this happens, or if this is true, then you would refer to a boolean, because a boolean stores only two values, true or false. It's binary.
Yeah, and we can demonstrate a little bit of how we would actually declare these in the IDE.
I have
So
another question.
Yeah, go ahead.
So, can you store full expressions?
Yeah, so if I wanted to say, are you saying like if I wanted to store, say if I had an integer data type and wanted to store, 5 plus 3, is that what you're asking, like an expression like that?
Yeah.
Yeah, you can
Or
do
with
that.
doubles. Can you also do it in doubles?
Yeah, if I wanted to store, say, 2.3 minus 1 or 1.8, I can do that as well. And we can demonstrate that on this Java compiler because, I want to show the actual concepts here now. So, this is just kind of like the class and method. We'll go over all this code like later, but for now, just kind of focus on the code that I'm going to be writing within these two brackets. So first of all, we can, just start off by defining a integer. So I'll just say int example is going to equal 3, and then we have our semicolon right here. And this is also a good time to introduce print statements. Print statements are going to be essential if you're just trying to test something out when it comes into the notion of like app development. But for right now, this is going to be kind of like the output. It's going to be like the output. Whenever I do a print statement, it's going to print, to this console right here. But this is what we're going to be using to actually create or manipulate our XML UIs and stuff like that. It's simply a kind of a filler for us actually creating an output. So this is an important statement for you to know. It goes system with the S being capital, and then dot, and then out, dot, ln, and then you have quotation marks on the right, which you want to print within those quotation marks. I want everyone to take a moment and write this down because this is very important. This is very important for printing anything in the console, and when you're printing stuff at the console, it's very important for debugging and testing different things. It's very handy, it's very useful. So I do want everyone to take a minute to write this down. I'll give you like 30 seconds and I'll continue. Okay, so then if I want to say print this integer out, then what I can do is I can have a quotation mark right here because remember when we're printing a string, we always need a quotation mark. So I would want to print, say, the value of int example is, and then I can do right here a plus sign. And what this plus sign means essentially is something called concatenation. And what I'm doing is I'm going to be taking this string right here, and I'm going to be combining it with an integer value essentially. Now, if I do example then, and if I hit print right here, how do I actually execute? Yeah, if I hit execute right here, then why are we having
a semicolon?
Oh yeah, semicolon. There you go. Never forget your semicolons right there. Okay, there we go. And it prints out right there. So this is a very important concept to know. If I want to print a string, it always needs to be in quotation marks, and for variables, it never has to be in quotation marks. If if I have a string, it would never be in quote. If I have a string, like just like a pre kind of coded value, it needs to be within quotation marks. But if it's not, if it's like a variable, then it doesn't have to be in quotation marks. So now if I, go on a simpler basis of this, and I just want to print out, say, the value example without having this text, I just erase this and then go here, and it'll just print 3. And there you go. So, as you can see, no quotation marks. If I had the quotation marks, then it's going to print example out, and that's not what we want. And the same thing goes for string. We can try doing some more data types now. So if I do string, notice I'm forgot to raise the int right there. If I do string, notice I'm capitalizing my S, and then I do example. This is obviously going to run an error if I execute it. I'll show you this actually. If I have a wrong data type, then I'll show you what happens. This is not going to work because you have a string and we're putting a data type in. It's not going to work. See, you have your error right there. So if I have a string, I have to do quotation mark and do hello world. And now if I print this, it'll print out hello world. So notice how if I have a variable, I never have to use quotation marks with the variable. And now let's try changing the value of this variable. Let's try example equals quotation marks goodbye. Now if we do that and we print out example again, then it'll print out goodbye. So there you go. That's how you kind of change variables. And I think someone asked, if I change this to a different data type, will it work? And the answer to that is no, and I'll demonstrate that. If I make this, for example, 4 as an integer, and execute, it's going to do an error. So see incompatible types, int cannot be converted to string. So you have to keep the types the same. But that's how you declare a variable. And we can do a double as well, just because we've done all of the other ones. And we can also do a Boolean.
I have a question.
Did someone say question?
So right now it's a string example, but could you change it to int example?
Yeah, of course I can. Yeah, I'll do that right now. If you want me to change it to int, if I make it int.
No, I mean so after that you could redefine it as a integer by saying int example 4 or something.
No, I can't do that. And the reason is because we'll try that out actually, and I'll show you why. Because if I do because this is string right here, and you want an int example, string example, and then we have int example. This is what you're talking about right here, right?
Yes.
So if I do this, and then if I tell Java, if I refer back to example in any way, the compiler is going to be confused which example I'm referring to, because there's 2 examples now. There's a string and there's an int, so it's not going to know what to print out, and that's why you can't do that. And I'll show you now. If I hit execute, it's going to do an error. See, there's an example. So it's saying, the variable example is already defined. Like there's literally 2 of them, so that's why it's not working. If I change this to example 1, then there's no problem. It's going to print out hello world. So you can't really redefine it to another type. The type itself is set in stone. That is concrete, but the value itself is not. So that's your takeaway. If you want to write that down, go ahead. Type of variable is set in stone. That's concrete, but the value isn't. The value is as flexible as you want it to be. It can change this 100 times and not have a problem, as long as it's the same type. And now we can do a double and Boolean. So do double. And I think someone also mentioned expressions, so I'd also do that. So we'll do, say, 3.3 plus 4.2. So this should print out as 7.5. And if I do this, it'll print out as, there you go, 7.5. So you can define via expressions too. So there you go. I think that's a pretty good kind of overview of code, but I highly recommend you kind of play around with the ID. Now I'm going to send this link later on in chat, And usually we don't give you guys any homework, but it's very essential for you to kind of get used to how Java works. And there's only so much explaining we can do within an hour-long class. So I highly recommend, you just kind of go on Java and try different things. Like you're asking me a lot of good questions. You're asking me things about expressions. I had different data types, and these are all amazing questions. But we only have time in class to answer so many of them. So I highly recommend. I'm going to send you this link, and you can play around. You can answer a lot of these questions yourself. As you saw, I just answered the question about expressions, and I answered the one about different data types, and so you can try it on your own and also get used to it. And you'll get better at writing the code itself if you also try this out. So I'll send this link right now, actually, just in the chat, and then we'll move on with the
You
presentation.
can send it in the WhatsApp and the email as well.
Yeah.
And if you have any other questions, like while you're trying it out, then you can just like reach out to us on WhatsApp or email.
Yeah, if you guys have any questions, outside of class, definitely reach out via WhatsApp or email.
Can we use REPL instead of this?
Can we use, sorry, what?
REPL.
Is that under online ID pretty much? Is it like the
Yeah.
same? Yeah, I mean, it doesn't matter. I'm just setting this one as a reference point. If you don't have anything else, or if you don't know of anything else, you can use this one. It has it has our seal of approval, I guess, if you want to call it. But yeah, if you know something, then you can use that as well. It's perfectly fine. Okay, so we'll move on now. We get these primitive data types and how to define variables. I think everyone is pretty good on that and has a solid understanding. So we'll move on to, there's your examples right there. We did a lot of this in the ID, but as you can see, there's the general trend of having the data type first, and then you have the name of the data, and you have your equal sign. You have the actual value, which lines up with the data type. If it's a string, you have it in quotations and the semicolon. So there's your examples right there. Now I think Ayush can talk about if statements.
Yeah. So, okay. So when you're doing programming, you're not going to always want the same thing to happen, right? Depending on who's using your app or what actually is happening in your app, you want different things to be happening. You don't want the same thing to happen over and over. So a way you can do this in Java and pretty much any programming language is using an if statement. It's called an if statement, and basically what an if statement does is it's basically a condition-based statement that performs different actions. And what does this mean? Well, just look at the chart on the right? So you start off at the top there with that little circle. That's you, and that's what you input. And into that condition, it checks that. So let's just go through an example, right? So we have an app that automatically calculates your BMI, and obviously they want to do it differently for like if you are above 18 or if you're below 18. So you would put in your age. So that circle at the top would be your age, and then the condition will be if age is greater than 18, then it'll calculate it based on the 18 plus 1, and then else it will calculate based on the 18 minus 1, right? So that's many apps and many things. You never want to do the same thing for the same users, and whenever you want to have like a different thing happen when something else happens, right? You want to use an if statement. And let's use an example from the war card game actually. So, see, if one card is a 5 of spades, right? Your card is a 5 of spades, and the computer's card is a 7 of spades. So what you would do there is you would use an if statement to figure out whose is bigger. So you'd say if CPU card is greater than, I guess, your card, and then inside that if statement, if the CPU is greater than yours, then you would add 1 to the CPU score. Otherwise, you would add 1 to your score, because you would know that if theirs is not greater, that means yours is greater. So there's a lot of things that you can do with an if statement that really can make your code a lot more dynamic and just make it a lot better, because you never want to do the same thing.
And we have, I think, an example right here of the code. And this is a pretty simple example right here, but essentially we have, this is kind of how the syntax works actually. So if we have, we just first have if, and then we have the condition in the right here in the between the parentheses, and we have an opening bracket, and then we do what is going to happen if the condition is correct, and we have a semicolon as always. And notice that there's no semicolon at the end of the if statement, and this is actually right. This is how it's supposed to be. This is one of the very few exceptions. If you have anything as a bracket, if you have like an if statement or something, if you behind this bracket, if like these two lines of code will not have semicolons at the end. So these are two exceptions right here. Whenever you open an if statement, whenever you close an if statement, there's no semicolon at the end. So know that, otherwise you're gonna have an error. If I put a semicolon right here, it's gonna mess everything up. It's not gonna run. So this is important to know. And then after that, I just have my print statement within. And this is kind of the print statement that we kind of asked you guys to write down. So, and semicolon right there. So this is like the basic syntax. We have the if, and you have the condition within a pair of parentheses, opening bracket, then what you want to do, and then closing bracket. And here is a good sample right here. So this is kind of calculating similar to what I usually saying with the BMI example. So earlier in the code, we have just earlier in the code, it's going to be assumed that the user enters their age in, and it says right here, if user is less than 18, then it prints out that the user is younger than 18 years old. And then if the user is equal to 18 years old, then it's going to print out it's equal to 18. And there's no other possibility. If they're equal or young, if they're not equal or younger to 18, then they have to be older. There's no other possibility. So that's why we don't need a condition right here. Just prints in the user is this should be older or more than 18 years old. So just disregard that. It should be more than. But right here, notice how we're using a kind of a different nested structure right here. So if you can test out multiple conditions. If I say the first condition is going to be if, and then I do else if, and I can do another else if, and you can essentially do infinite conditions like that. I don't think I'm doing a good job of explaining it. Maybe do you think you can explain that better?
Yeah. So when you're creating an if statement, when you're creating an if statement, you don't always want to. There's not always going to be like one thing or the other, right? So if user's less than 18, and then else that something else, right? There's not always like one or the other. So if you want to do like if there's like a 5 or 10 or even one more different thing that you want to do, then you're using this statement called else if. And basically you can add as many else ifs as you want, but you can only add one if and one else. So to each one of these are called like if else bracket or if else chains. You can only add one if statement, which is at the very top, and then one else statement, which is at the very bottom. And and they have to be there can only be one of each, and in between you can add as many else if statements as you want. So for example, like this is a very rudimentary example, but for example, if a user enters in the letter of you just tell a user to enter in a letter A through Z, right? And you say if letter is equal to A, then you would say system.print line A. Else if, but you don't want, so if you're only using else, then you're not going to be able to do something for all the other letters, right? But if you want to do something for B, C, D, E, F, G, you're going to have to use else if. You're going to say else if letter is equal to B, then system.out.println B. Else if letter is equal to C, system.out.println C. So that's really why an else if is really advantageous, is because you can do more than one or the other thing.
Yeah, and I think if we show an example, it'll definitely make more sense. And here, I'll show like a good example right here. So if we have, I'll get rid of this code. So just setting up the context. Let's say we have a lottery, and on like a regular scale, people would usually choose like 5-digit or 6-digit numbers, right, for the lottery. And if you have like the right number, then they get like the jackpot. But in our case, let's say they're only choosing numbers from 1 through 100, and there are 5 winning numbers, and we can make these numbers. I'll write them down right here on a piece of paper. You can make these numbers, say 13, 27, 94, and 63. So we'll just go with 4. And if you do 13, you get a let's say you get a $500 jackpot if you guess 13. If you do 27, we'll give you $1,000 jackpot. And then for 94, we'd say $2,000 jackpot. And then for 63, we can do a $5,000 jackpot. So essentially what this program is going to do is it's going to take the number that they input in, and it's going to then use if statements to figure out if their numbers match up with any of the jackpot numbers. And if not, then it's going to tell them that they didn't win a prize. And if they did, it's going to tell them what prize they won. So, let's get started with that. Let's say, just for simplicity's sake, we're going to say that, instead of inputting like an actual number, we're just going to create a variable, and that variable would be equal to, what the user would actually put in. So say user input number right here, and we'll just kind of define this as something random. We'll just call it 50 for now. So I forgot to define int. And now what I'm going to do is I'm going to say if user input number is equal, and you need two equal signs right here. This is just something that you kind of need to know. Whenever you're using an if statement, you need to have two equal signs. You'll see that on the example code right here, right? You need to have two equal signs when you're checking for equivalency on the if statement. So I definitely recommend writing that down, and I'll explain why in a little bit. So if I say if user input number equals 13, which is their first jackpot number, parentheses right here, then system dot out dot len, you won the $500 jackpot. And so now we have that done. Now say if we want to check, if they have another number, if they have say 27, if it's not 13, then we want to check if they want any of the other jackpots. So let's see if user input equals 27. Then we have to see, then we have to say, you won the $1,000 jackpot. And now if I say, if, there should be else if, sorry, there should be else if right here. You can only have, like I said, you can only have one if, and after that, everything has to be else if, and you can have one else. So else if, then user input number is equal to 94. Then we say the $2,000 jackpot. And now if they guess 63, then they get the 5,000. So we say else if user input number equals 63, okay, so now we have set up. And now we want to tell them if they have any other number, they didn't win anything. So for that, we'd have to do else, because we don't have to individually check for, the rest of the, numbers from 0 to 100. We can just say if it's any other number, they didn't win anything. So we don't need a condition, because these are the only conditions that apply. So now if I say, else, and I do, system dot out, Put semicolons at the end of all of these. Remember your semicolons, guys. We just have that, and now we can kind of put this onto the test and see how it actually works. So if I compile this right now with the input number being 50, it's going to print this last segment out because none of the conditions matched up. So if I do that, there we go. And then say if I change this to 13, and it'll say you won the $500 jackpot. If I keep on changing this to say 63, and it'll say we won the $5,000 jackpot. So essentially there's different conditions here. You can have unlimited conditions here. In this case, in this one right here we had mainly 2 conditions right here, but right here I created 1, 2, 3, 4 conditions right here. So you can have unlimited conditions with these else if statements, and you can create different outcomes for each one. For this one says 500, for this one says 1,000, 2,000, 5,000. And then this else is kind of your all-encompassing bracket, essentially. Say if, none of these conditions are true, then what should the program do? If none of these numbers are, if user input number is equal to none of these numbers, then what should the program do? And that's kind of what the else statement is. It does your kind of catch-all type thing and says you didn't win anything. So that's kind of, yeah, go ahead.
So everything is indented. Is that necessary like in Python, or is it like not necessary?
Yeah, you need to indent because I can show you what happens if I don't indent. If I say make this go like right here and make this.
So if you don't indent that, then it's not in the class anymore?
Like, yeah, it kind of messes up, I'm fairly sure. I guess not. But I mean, I think, yeah, I don't think you need to indent then, but I would highly recommend indenting just to like make your code readable, because if you indent, it's like it just looks way better. Let me see if let me just try to make sure for you though. So let me make this 27 and see if it works. Yeah, I mean, I guess it doesn't really make a difference, but I would highly recommend indenting just because this is so much easier to read than if I, completely messed up the indent. So I definitely recommend indenting. It makes the code easier for you to read when you come back to it.
Okay.
But yeah, so that's how if statements work. And then I'll explain why we're using two equal signs right here now. So whenever you're checking something for equivalency, if you're checking to see if like a value is equal to
Python, equal does not equal to.
Exactly. Yeah, whoever said that is correct. The equal sign does not equals to. The equal sign is what's called an assignment operator. Whenever you're assigning a new variable, whenever I'm assigning this value 27 to user input number, I'm not using this as like a user input number is equal to 27. I'm saying put the value 27 into the variable, match the value 27 to the variable user input number. I'm assigning the value 27 to user input number. But here what I'm doing is I'm doing a Boolean, I'm doing like a condition right here. I'm saying, if user input number equals 13 is true, like if this is true, I'm checking for equivalency. If these two are equal, then do this. If user input number is equal to 27, then do this. But here I'm not saying integer user input number is equal. I'm assigning the value 27 to user input number. Is everyone clear with that distinction? So whenever you're doing checking for equals, if you're seeing if two values are equal, then you use two equal signs. And if you're assigning, you only use one. Is everyone clear with that? Because this is very important. If I, erase this equal sign, we're going to have an error. See, there you go. So you need to make sure that whenever you're checking if two values are equal, you use two equal signs. And if you're assigning, you only use one. This is very important. I want everyone to write this down. So yeah. Do you have any other questions or comments? Okay. If not, then we will move on to for loops.
What does the 3 = sign mean?
There is no 3 equal signs, but yeah. Ayush, you can talk about for
There is a
loops.
3 equal sign in some languages, but not Java.
Yeah, there's nothing in Java as far as I know. Okay, you want to talk about for loops? Ayush? Okay, I don't know if Ayush is there, but I'll talk about for loops. So, what a for loop does is it essentially goes through, some part of a program mold. Hello?
Yeah, can you hear me now?
Yeah, okay, yeah. All right.
Yeah, sorry about that. Okay.
Yep, you're good.
Okay. So basically, a for loop is something that you can use to do something more than once without actually copy pasting it and basically taking up a lot of space and time by copy pasting it. So say you want to print something to the console like 100 times. You what's your options there? So what with the without knowing how to do a for loop, I think your best option would be to copy paste that line 100 times, right? And yes, you can do that, but what if you want to do it a million times, right? What if you want to do it 10 million times? Like, at that point, it's pretty much impossible. Even if you're brute forcing it, it's pretty much impossible. So if a for loop really allows you to maximize your efficiency with repeating certain tasks. So basically, a for loop is an iterative statement that goes through a certain part of program multiple times, based on a condition. So and this is how a boolean comes into play, like we're talking about earlier. A boolean is either true or false. So it uses that to essentially create a loop where once a condition is broken, then it'll stop. So an if statement is a for loop is basically an if statement that executes multiple times, and it just keeps on doing that task until a certain condition is false. So, for example, you want to keep looping something until I guess a counter is 100, right? And you want to keep printing to the console until or 100 times, right? So you're going to create a counter variable called I, for example, and we'll show you the syntax of this later on. But for example, you create a variable called I, and you set it equal to 0, and then you keep adding 1 to that every single time you do it. So this way, you're able to actually print to the console 100 times without actually typing it. That would be 3 lines of code instead of 100 lines of code. So that's why a for loop really works well for anything you want to do multiple times.
You can explain the syntax. Yeah.
Yeah, so here's some example code for a for loop. So there's some things that are similar to an if statement here and different. So the basic structure is kind of similar to an if statement. You have the name for at the very front, and then you have parentheses. You have stuff inside the parentheses, and then you have an opening bracket and then a closing bracket after you put whatever you want to be in it, right? So it's kind of similar to an if statement in that regard. But what's different is, firstly, you don't say if, you say for. The keyword there is for, the first word there, and then inside the parentheses, this is how you create your conditional statement, and this is how the for loop knows when to start and end. So basically, how this works is there's 3 different things that you need to insert into a for loop. The first one is you're creating a new variable. And whenever you have a for loop, you need to, this is a requirement, and you write this down. These 3 things are really important for a for loop. The first one is variable declaration, and you're basically creating a new integer, and typically you call this I for most for loops. Like in Java, you just call this I, but in theory you can call it whatever you want, but I stands for like iteration. And so int I is equal to 1, right? You're going to start off with 1, and then you put a semicolon because you're just ending the line of code there. For the second one, you say this is a conditional statement. So you want to go until I is less than or equal to 10. And what that's going to tell the for loop is to repeat that system.out.println the value of I is I 10 times, right? It's going to keep on going until I is less than 10, and once or less than or equal to 10. And once that's false, once it's 11, it's not going to do it anymore. It's just going to stop and move on to the rest of the code.
This should be greater than, because if it's less than, it only run once because 1 is less than.
Oh yeah, yeah.
So it should be. Yeah, that's good.
I think the greater
Sorry
again
about that.
goes first. I think.
Oh, my bad.
So you declare a variable to make a condition, then say how the variable changes.
Yes, exactly. And then the third parameter is how you're changing it. And typically you just add 1 to it, but in theory you could add 2, 3, 4, but usually you want to add 1. And in Java, to add, this would be the same thing as saying I is equal to I plus 1. But
I
in
have a
Java there's a
question.
shorter form, say I plus plus. Yeah. What's your question?
There's also r plus equals 1, right?
Yeah, that's another thing.
And is there minus minus and
Yeah,
stuff
there's
like
minus
that?
minus. If you want to go downwards, you could do minus minus as well.
Okay.
Yeah, so those are the 3 things you really need for every single for loop. Variable declaration, conditional statement, and incrementation slash decrementation. And then you would have your opening and closing brackets, and everything inside of those brackets would be what you're repeating. So in this case, it would be printing that line of code. Yeah.
All right, you want to do an example or?
I don't really. I can pull some. How much time do we have left in the meeting?
I think we have like 10 minutes probably, and then it's like the last slide
Oh, we
though.
have 10
So
minutes. Okay.
there's like nothing else. I'm fairly sure we have like
Okay.
probably around 10
Yeah,
minutes.
I can.
So let's
Can you,
stop presenting.
let me just pull up the link you sent and then.
Yeah.
Okay.
Yeah, this is the last thing we're doing. So I think we'll have.
So
So,
when we downloaded Java, what are we going to do with that?
yeah, we're gonna be using that to finish up the app in Android Studio. We'll be going over that in our next class and the class after. So definitely doing that.
Okay.
Okay. Can you guys see my screen?
Yeah, we can see it.
Let me make sure the stream can see it. Okay. Yeah, I can. Okay. So basically, we have our basic class here. We have our static void main. Everything goes inside this, as we were talking about earlier. We don't need that print statement for now. So what I'm gonna do is I want to print out the numbers 1 through 10. Let's start off with the numbers 1 through 10, and I just want to simply print on a single individual line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simple code. So let's do that. So the first thing you do is define the keyword, and the keyword here is 4. And then you would say parentheses, and here's where you'd add those 3 main things. So the first one is declaring a variable, and this we're going to call it int I. And you typically would start with 0 because you would increment from 0 onwards. So yeah, that's pretty standard. I think in the other example we had 1 for some reason, but you would typically start with 0 as I. And then secondly, you would say I is less than, and this is a conditional statement, by the way. So you would figure out what you would want to have be like the climax of what you want to do. So you were saying I is less than 10. So you're gonna keep on running this code until I is less than 10. Because so then the third statement would be, or actually, that's good. So the third statement would
Wouldn't that be an infinite loop?
Why?
It wouldn't be an infinite loop, but it would only be a loop that iterates once because 0 is already less than 10. So it would only iterate once.
Does it stop when I is less than 10? Or
Yeah.
does it start?
It stops when I is
So that's actually a
less
good
than
question. It stops.
So it stops when I stops being less than 10?
Yes.
Okay.
So basically, you can think about it like this. If you can tell, if this statement here is true, then it'll continue running. And if this statement here is false, it'll stop. So basically, you can think of this as a true or false statement. If this is true, it keeps running. If it's false, it doesn't run. And then the last thing would be just incrementing it. So we do I++. So now we need to add our brackets. So I would just do that, and then go down here. So we have our starting and ending bracket. So everything inside this starting and ending bracket would be what is going to be iterating and what we're going to be repeating. So right now, I just want to print to the console 1 through 10, right? So I'm just going to do system dot out dot print line I, and that should print I 10 times, right? And I forgot a semicolon, so let's see it. Oh, it printed it 9 times, or did it? No, it actually printed it 10 times because it started with 0. So if actually that's what you okay. So this variable right here is what you start off with. So when you're initializing this, that's what you start off with. So if you want to start off with 1, then it would actually start off with 1 and then go through 1 through 10 instead of saying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that. 1, 2, 3, 4. Oh, okay. So there's actually So it started off with 1 now, but it didn't include 10. So this is only 9 numbers now, right? So how do you fix that? So that's because when you're running a for loop, it's not gonna do it the 10th time unless you say equal to,
Or less than equal to,
less
right?
less than or equal to. Otherwise, it's gonna say, hey, I is less than 9, so or 9 is less than 10, and then do that, and then it's going to say 10 is less than 10, and that will be false. 10 is less than 10 is always going to be false, so then this for loop would stop. But if we say I is less than or equal to 10, then it'd say 10 is less than or equal to 10, and that would be true, so then it would run it the last time. So we can see that again here when I execute it, and now it has 1 through 10. So I have a question for let's see.
We only have 4 minutes, by the way.
Yeah. Okay. So Ken, how would I do this 100 times? What would I change?
I is greater than or equal to 100.
Yep, that's what I'd do. And now it's gonna print this 100 times.
Be less than or equal to, but yeah.
Yeah.
Or could you also do I plus equals 0.1?
Yeah, you can do that as well. There's different ways to do it. That's a good solution as well. Yeah. Yeah, there's multiple ways to think about it. Now you're kind of reaching this point in coding where there's not only one solution. You can do the same thing with different solutions. That's perfectly acceptable. So you can keep on going, and there's lots of applications to for loop. Right now it might be kind of difficult to explain those applications, but once we kind of get to the work hard game, it'll make more sense. But yeah, you're pretty much going all the way to 10,000. It's something you'd have to do each and every single number for previously, but now you're doing it all in kind of one 3-line piece of code.
Are we also going to do while loops?
We might do while loops next time, depending on how much and/or Java we need to cover. So
Okay.
yeah.
Yeah. And while loop is pretty similar. It follows like the similar structure of
Also,
you
they
want
can
a
be more
variable to
complex.
if a variable is true, then it continues running it. So it's pretty similar, and yeah, we can cover it next time if we.
A for loop has a set number of times it's running. Like this for loop will only at the current state, it's only going to run 10,000 times. It's going to run exactly 10,000 times, not 9,999, not 10,001 times. It's very set. It's precise at 10,000. But with the while loop, it's more. It depends on the conditions. You can have a while loop run for one iteration. It can run 3 times. Another time can run 7. Another time can run 8. There's no set value, and that's kind of like the I guess introduction to while loops. So we'll see if we have time to go over that next session, because it's not essential to the work hard game, I think, but if we have time, we'll definitely try to cover it. And I don't think we have much time, so if you have any questions or anything.
I think we have under a minute, so
Yeah.
I think tomorrow we'll go over Android, Java, and start getting into the work hard game backend. So yeah.
Okay. All right. I'll see you guys tomorrow, 5 p.m. EST, and we'll have the stream uploaded and sent out to you guys. All right. Goodbye.
All right. See you, everyone.
Bye.